Okay, welcome back. Sorry, I had a brain fart there. We were talking about margins, active versus passive. So active margins, they're found on a leading edge of the continental crust near convergent or transform plate boundaries. So near a boundary, specifically convergent or transform. There's a lot of stuff going on, a lot of interacting between the continental crust and oceanic crust, making this coastline very active, hence active margin. Typically, you have very narrow continental shelves and very steep slopes. There are things like oceanic trenches found at these margins. So, for instance, at convergent boundaries, as the oceanic plate subducts below the continental crust at a convergent boundary, that point kind of where they're intersecting and that oceanic crust is bringing down with it that continental crust, it forms a very deep trench. Common site, active margins, common sites of tectonic activity, earthquakes, volcanoes, uplift. The margins along plate boundaries typically have, these type of plate boundaries typically have rugged topography, very mountainous, and you'll see some examples here shortly. So again, in this case, this is a convergent boundary. I know this because of this subducting plate. So we have the oceanic crust, continental crust, very narrow shelves, and then it launches pretty much right into the slope before you get to the continent. Before there's almost no rise at all. It just hits oceanic plate. So very narrow shelf, very steep slope. And the geology, again, mountainous, volcanoes, earthquakes, etc. Here's another look at it. Again, very narrow shelf, and then slope. Trenches are common here, but those aren't trees. Those are mountains. So very rugged topography. Almost night and day between active margins and passive margins. These are found at every ocean and continental transition that is not near a boundary. So these margins are not near a boundary. Typically very wide shelves, very gentle, gentle slopes. No trenches along passive margins, so things don't get very, 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 very deep in the ocean near passive margins, typically. Little to no tectonic activity. The dominant process of geology on a passive margin, therefore, is weathering and erosional processes. This leads to very low relief, so flat land. Active margins, you have, boundaries, you have earthquakes, volcanoes, uplift, things moving around. Well, passive margins, you don't typically have that, so time just takes its toll. The weathering and the erosion process are what's very dominant. So very wide shelf, somewhat gentle slope before you get to the oceanic crust. So again, much wider shelf, much gentler slope, and again, very flat terrain, very flat terrain. So again, it's almost night and day. So looking at active continental margins, there's a lot of stuff going on West Coast. Passive margins, really not much going on. Really not much going on. You know what? I'll tell you what, before we proceed, let me give you another part of the super secret code. This is all kind of like a mathy one. So in the first video, I gave you something. In the second video, I told you to mathematically add an additional number to that. So I want you to take that that answer that you got and then divide it by 2. Okay? So with the first video, the second video, you added those two numbers together, like on a calculator, like you added them mathematically. Now take that answer and divide it by 2. You got me? Divide it by 2. I'll say it again. Divide it by 2. So let's look at again the plate tectonics, or the plate boundaries around the North American plate. Again, right along a plate boundary, a majority of the West Coast, so it's an active margin. But again, the East Coast, not near a plate boundary, so a passive margin. So what does that look like? California, West Coast, active margin. Again, very rugged terrain, very rugged terrain. Oregon, West Coast, very rugged terrain. Let's look at the other side. Let's look at the East Coast. Look at Florida. Pretty flat. South Carolina, East Coast, pretty flat. Texas, along the Gulf Coast, which is still not even near a plate boundary, really flat. All right, so weathering and erosion are the dominant processes on the East Coast, passive margin, whereas volcanic activity, earthquakes, tectonic uplift is very dominant on the West Coast. active margins. Louisiana, another example on the Gulf Coast, which is an active margin. It's the southeastern portion of the U.S. Again, just very flat before you hit the ocean. Same deal. Again, you could do the same thing. If you looked at images along the west coast of South America, it'd be very rugged terrain on the west coast. On the east coast, for the most part, more flat, more gentle terrain. It's just how it works out. All right, let's go ahead and pause there. So not only does tectonic activity play a part in shaping the coast, but so does the motion of the ocean, which does so, and the ocean moves in a few different ways. So that's what we'll talk about in just a minute. I'll see you then.